everyone, welcome to topic 7.4, two-way ANOVA. So what we're going to do is we're going to start with two-way ANOVA with no interaction and then move on to two-way ANOVA with interaction. Some examples of the two-way ANOVA we might be looking at, is the brand of golf club and the brand of golf ball influencing the average hitting distance, or we might want to determine if career type and educational background influence average salary. Okay, so here's an example. We're looking at the two-way ANOVA with no interaction. In this example, an undergraduate student is trying to decide which career to pursue based on salary. She is considering three fields: education, finance and medical. The average salaries for each field are 43.5, 54.5 and 60.2 respectively. Using a one-way ANOVA, we find that the differences are not significant. If we then consider educational level, we may see a different result. Here we have 12 people, one in each category, and we have the salary for each person relating to each of the 12 categories. So for example, someone with a bachelor degree and in the medical services earns $43,000. The means for fields of employment, or factor A, are presented as 43.5, 54.5 and 60.25 respectively. The means for educational level, factor B, are 23 for high school, 41 for bachelors, 55.3 for masters and 91.67 for PhD. The grand mean is shown, it's 52.75. You can see that with the X bar. Okay, so here's the layout for the ANOVA output. This type of two-way ANOVA is known as our randomized block design. We now have variability for education level, factor B, variability for employment field, factor A, and variability due to chance. Also total variability is presented. Until we account for the variability in education levels, we can't determine the effect of employment on average salaries. Here are the ANOVA results for our example. As you can see, employment fields are significant as the p-value of 0.03 is less than an alpha level of 0.05. Therefore, after controlling for education level, which is significant also as the p-value is 0.000086, the average salaries differ by employment field, as shown by the p-value of 0.03. Now let's consider two-way ANOVA with interaction. Here we are comparing the means for one factor, known as the main effect for factor A, then the means for the other factor, also known as the main effect, but for factor B, then the means for different levels or combinations of the two factors, known as the interaction of A and B. The ANOVA output shows the sum of squares for factor A, the sum of squares for factor B, the sum of squares for the interaction of factor A and B, and the sum of squares error. So what is an interaction? Well, this means the effect of one factor on another. Take the golf example. If we are including club types and ball types, it may be that a certain club with a certain ball results in an average hitting distance that is greater than a different club with a different ball, or a different club with the same ball, etc. You can imagine there are many different combinations. For example, if we have 3 golf clubs and 4 golf balls, then what we're looking at is 12 different means for the 12 different combinations of club type and ball type. Okay, so now back to our salary example. The two categories, employment sector and education, may interact differently depending on the sector. Here we have some different data for salaries relating to education level and field of employment. Now the values in the cells are means. For example, the average salary of 3 employees has been calculated for each internal cell. So for the 3 people with a bachelor degree working in the medical services area, their average salary is $43,330. So here is the Excel output for the two-way ANOVA with an interaction term. Now we have values for 3 F-test statistics as well as corresponding p-values and critical values. The sample bracket rows refers to the main effect for education levels, which we can see is significant. The columns refers to the main effect for employment fields, which again is significant. Before we interpret these main effects, we need to check the interaction. Because the interaction is significant, we need to be cautious in interpreting the main effects. The significant interaction means that the average annual income across the different education levels is higher in some employment fields than in others. If the interaction is not significant, then we can more easily interpret the main effects. Okay, that's two-way ANOVA.